Okay, so new packet today. The things that are coming up are project 4 will be assigned next week, and quiz 4 will be coming up shortly after that. So your new packet titled Packet 2, it has one reference sheet at the front, which we're going to be using today. And this you can use on quizzes and tests in the future. All right, so we're on class number 13, trig substitutions. So this is one more, last one, technique for integration, okay? So we now have U substitutions, by parts, partial fractions, and now we're going to have trig substitutions. So 4 techniques for integration. All right, looking at these first 2 examples here, why would I not use partial fractions on them? They can't be reduced. The denominators don't factor, right? So there's no way to break it up into the sum of 2 fractions. Okay. Right, they're already irreducible quadratics, and the numerators are already linear terms. So even if I tried to break it up, it would just come out looking exactly the way it already does, right? So I do a bunch of work for nothing. But there are techniques we can use. There is a technique we can use to do these guys called trig substitutions. All right, so a trig substitution can be used when you're simplifying integrals that involve a squared plus or minus x squared, with or without a square root symbol in there somewhere. So I'm going to do a strange substitution to make this integral that looks really ugly possible. And then after I walk us through the method, I'll show you the reference sheet that can help you decide what substitution to make, what substitution will be helpful. All right, so the key here is we're going to let x, we're going to substitute anywhere we see an x with a 3 sine theta. Okay, so right now that feels a little magical. I just pulled that out of nowhere. We'll talk about where that comes from in a few minutes. But let's just see what happens when you do that. If we're going to let x be 3 sine theta, okay, then what is dx d theta equal? Just the derivative of this guy. 3 cosine theta. Oops. 3 cosine theta. So if I just want plain old dx, what's that equal? 3 cosine theta d theta. All right, so now I've got all my substitutions ready to go. I'm just going to replace anywhere I see an x in my integral, replace it with a 3 sine theta. And when I see a dx, I have to replace it with 3 cosine theta d theta. So this becomes the integral of 1 over the square root of 9 minus, instead of x squared, I'm replacing x's with 3 sine thetas. So what do you get when you square 3 sine theta? 9 sine squared theta. Great. Okay. And then dx, I'm going to replace with 3 cosine theta d theta. All right, so now most of what's left is just some simplifying, doing some algebra inside the integral. I'm going to simplify as much as I can. Hopefully this will turn into something that's easy to integrate. All right, so looking at the denominator of this fraction, there's a 9 in both terms. Just factor out that 9. So this becomes the integral of 1 over the square root of 9 times 1 minus sine squared theta times 3 cosine theta d theta. Once you do a lot of these, you can start to do several steps in your head, but I'm going to write this down in minute detail for the first time, okay? What is the square root of 9? 3, so I can pull that out of the radical, right? So this becomes 1 over 3 times the square root of 1 minus sine squared theta times 3 cosine theta d theta. All right, so I already have one really nice cancellation. My 3 is canceling here. Got one up top, one on the bottom, they cancel. Think back to your pre-calc course. What's 1 minus sine squared equal? Cosine squared. Yeah, that's just the Pythagorean identity. I'll just write it as a little aside here. Sine squared theta plus cosine squared theta is always 1. So if I subtract sine squared theta from both sides, I get 1 minus sine squared theta is cosine squared theta. Everybody remembers that? Okay. So I'm going to make that substitution in my integral. Replace the 1 minus sine squared with a cosine squared. So this is the integral of 1 over the square root. Instead of 1 minus sine squared, I'm going to write cosine squared. And then I have times cosine theta d theta. What is the square root of cosine squared? Cosine. So this becomes the integral of 1 over cosine theta times cosine theta d theta. I have another nice cancellation here. Cosine thetas cancel. So this just becomes the integral of 1 d theta. What is the antiderivative of 1? When my variable is theta? Theta, yeah, I heard an x. Okay, so it's theta plus c. So it turned into something easy to take an integral of. I'm not quite done because my original problem had x's in it, not thetas, right? You scroll back up to remind yourself. My original problem was the integral of 1 over radical 9 minus x squared dx. So my answer should have x's in it. So I have to somehow convert this theta back to an x. What's my relationship between x and theta? X equals 3 sine theta. That's what the very first thing I wrote down, right? So what does theta equal? Arc sine of x over 3. You just solve it for theta. So I'll write that down. So x is 3 sine theta. X equals 3 sine theta. So I'm just going to solve for theta here. First divide by 3. So sine theta is x over 3. Then to get theta by itself, take the inverse sine of both sides, also known as the arc sine. So you get theta is the arc sine of x over 3. So then we put that back over here. So my final integral is arc sine x over 3 plus c. So it came out all nice and pretty, right? It turned into something really easy to integrate by making this strange substitution, right? Where I let x be 3 sine theta. I replaced all my x's with 3 sine thetas. Your first page of this packet has a general guide on how to choose what your substitution should be for a trig substitution. So I'm going to take us back there for a second. When an expression involving x squared appears in the denominator of the integrand or under a square root sign, making a trig substitution may simplify the integral. Sometimes you need to complete the square before you do that, and there's a question in your activities that will walk you through that. So here's your guide for how to make the substitution. If you see an a squared minus x squared or radical a squared minus x squared, you can make a substitution x equals a sine theta. If you see a squared plus x squared or radical a squared plus x squared, make a substitution, x equals a tan theta. And then these fundamental trig identities will help you with your simplification, right? We used this one in the last example. You might use another form of the Pythagorean identity that tangent squared plus 1 is secant squared. Sometimes it's possible to simplify a bit further than we did, right? We came up with arcsine. Sometimes you can use a right triangle, a picture of a right triangle, to get even simpler than that. And there's another question in your activities that will take you through that step also. So these are your basic guidelines on how to choose what the substitution is. And once you've chosen the substitution, all the algebra should work out really nice and pretty, just like it did for us. Lots of things cancel, and you use the trig substitution to make things look nice, or the trig identity. All right, so I'm going to have you try a few on your own. Let me know if you have questions.